So I want to start by just acknowledging that most of what I'm going to show you today was not built by Val or I. And we actually don't understand all of it. So there's a community of developers, most of them volunteers, some of them coming to us through hackathons, others through programs like Google Summer of Code, who built a lot of what I'm going to show you today. If you want to try to follow some of the links that I've put into this presentation, you can go to orcasound.net/talks, and you'll see a link to this presentation. So I want to start by saying that our goals have shifted. We seem to be maniacally focused on the real-time problem, and it's manifesting in the last 5 years as real applications, needs for notifications for the forecast systems or the whale report alert system here in Canada. But there's always been a real-time need in the United States coming from the communities that generate most of these real-time detections. I think our grand challenge next year will be asking this question: how do we collaborate between California to Alaska on this grand challenge of conserving, taking action to conserve killer whales when they're calling to us? So I'll talk a bit more about conservation calls to action and the ways that some of this emerging technology could facilitate tackling the complex problems that we're all familiar with, the risks that these animals face, and they are complicated, but I think there's an opportunity in all of this emerging technology to design applications for their conservation, many of them, beyond just the whale report alert system or a forecasting system. So connecting back to the community scientists has always been one of our highest priorities. So we've been at this for about 20 years. We started at one location with some Colorado College students, Val's backyard in Harrow Strait. Green marker there on the top of that map. And in our heyday of funding our ocean protection plan, and from funding from NOAA in a 5-year grant, we had expanded to 5 locations from Nia Bay, in collaboration with the Macaw tribe, to the Seattle Aquarium in downtown Seattle. So our goal was to instrument all of the critical habitat of the southern Mexican killer whales, and you all have gotten quite a bit ahead of us now. We're down to 3 locations, but we're coming back in a new form that's characterized in the lower right here. Instead of government funding, we have crowdfunding. Instead of doing it all ourselves, we're collaborating with 19 different NGOs, each of which either hosts a hydrophone location, is responsible for maintaining it, or educates folks, uses the data products from the network, and makes us stronger in that way. So there's resilience in this new model, but it's been a steep learning curve involving all these new words like hackathons and cloud credits. So I'll give you a quick tour of what we've been doing. Is there a way to find this? Let's see. Is that a little better? I think that online folks don't see that. Okay, now you can see the title. So we began, as I was alluding to with Harold, with humans trying to listen on MP3 streams and local software at each location, trying to do the sorts of things that PAMGuard does now. So measuring ambient noise levels, and we had a tonal detector and an impulse detector. In the last 5 years, we've focused on not building an application that runs on your local machine next to the hydrophone, but on building web applications. So applications that are cloud-based and basically accessible for anybody through any browser on any device. And there's been a lot of challenges in there, and we're on about to release version 3 of the web app that makes it easy to listen. This is a picture of like what the deployment looks like. Typically, we try to put 2 hydrophones in the water for redundancy, but these are $300 hydrophones, not $3,000 or $10,000 hydrophones. And the software and the hardware that does the acquisition used to be a big XP box and sound cards and isolation amplifiers, and now it's in that green box next to Valentina there, and I'm holding that up. Like, all the software and hardware is in that box. It's a Raspberry Pi computer that costs $120, and a sound card from Lithuania that digitizes up to 192, 24 bits, 2 channels, and it's basically 100 euros. So the cost of our hardware has gone way down from thousands of dollars to a few $100s for the hardware. So 60 to 90% of our cost is still the hydrophone part. The software is free. We're currently streaming from 3 cabled sites, ones that were on that map. And this is a view of the current version of the web app. So you can pull it up on your phone at live.orcasound.net. And the big feature that we developed for version 2 was the ability to push that button and not just listen, but tell us when you're hearing something. So that's a community science interactivity that we didn't have. It used to be in Google spreadsheets, and it's increasingly, as Monica mentioned, on Facebook groups. But this allows us to get an annotation from a human with a timestamp in the audio data stream that we understand. So the other big challenge for us is like, how do you streaming the data happens through cloud service, and then how do you pay for the storage, and do you even store anything? So we've been storing lossy data, which is aimed at optimizing playback for humans. So we have audio data from the last 3 years, but not high quality audio data that you get out of many of your systems. So we're only digitizing at 48 kilohertz, so we don't resolve things above 24. And we're using hydrophones that don't have a flat frequency response. So it's not a good way to measure, say, shift noise levels or any source levels. But it is inexpensive. After 3 years, we're accumulating about a terabyte per year. And with if we actually pay the storage cost through Amazon S3, we're paying about $100 a month, so $30 per node. But the exciting thing is that you can get cloud credits, so you can get free storage from some of these big providers. And so you can see our costs were up around $100 a month, and then in April of 2020, we got $10,000 in credits, and so we had 0 costs for the last 2 years. And that has led us to applying for data sponsorship from Amazon, and so we're now part of the Open Data Registry, and so there's free data for the next 2 years. The other thing I wanted to talk about is, Oliver and Fabio and now other data scientists have taught us that in order to develop good models, you need good training data. And we had some, but we've generated a lot more. And that process is definitely ongoing. And the HALO program has facilitated and accelerated that wonderfully. I got a link here to, I think I shared this earlier in the chat, but this wiki on GitHub is where we try to track our month-to-month progress for the open data that is coming from the US side. And there's pointers here into other data that we can talk a bit more about annotated data later, but that's part of the thank you. It's like you've helped us understand what training data we need, and we generated quite a bit of it, and it's documented through this wiki. This is aimed almost exclusively at Southern resident killer whale calls. But we are now, this year starting to annotate clicks and whistles for Southern residents, and we're getting quite a few hours of big killer whales. We also had Emily Beerling, who joined us over the winter and spring. She'll talk tomorrow about humpback non-song vocalizations and her efforts to create a dictionary that works for us and for Orca Lab up in Johnston Strait. And then she's got about 4,000 annotations of the 12 different non-song vocalizations that she put in her catalog. So yeah, and there's more coming. We've, with Microsoft hackathons, one of which is going to go off on the 19th. We've built a couple of tools to generate more annotated data. So podcasts is one of them. It was used to train a model that's now been running a real-time inference system for the last 3 years. And that's generated a whole bunch of about 50 hours of 60-second samples, all of which have been labeled by either myself, Val, or Dave Bain using tags. So we're starting to build up a database of annotations, not of Southern resident signals, but of types of noise that you find that the hydrophones were using to monitor Southern residents. So you can learn more about these open source annotation tools and the real-time inference system at this website, AI4Orcas.net. And Dan will talk a little bit about the Orca Active Learning tool later in the session. This is a view of what the moderator interface looks like for the model that we have deployed. It's the simplest model we could imagine. It's just, is it a Southern Resident killer whale call of any type or not? So it's a binary classifier, and this is sort of how it presents the candidate. So a moderator gets an email or a text, and there's a link to the site. And then if you log in, anybody can see it. So it's a public dashboard and catalog, but to annotate it, you have to authenticate. If you say yes and hit submit, then that sends out notification email to a long list of end users, and anybody can be on that list. And it includes all the folks who are also listening as humans. So this combination, I guess I'm going to confidently go out on a limb and say, even though we have wonderful, talented people like Paul who are going to solve all of these problems for us, I'm going to predict that for the foreseeable future, there's going to be some humans in the loop, either validating the machine's output or just listening along, learning with the machine and continuing to teach it, because stuff keeps changing. And but overall, that combination of human and machines is very powerful. And we're getting to the point where I don't think we're missing any bouts. And we're starting to see when there are false negatives, like Monica mentioned. Sometimes, or I forget who said it, but somebody at East Point, maybe Lucy, has had experiences where they go by and they didn't say anything. They were in a resting state, or for whatever reason, there were no signals. So we're starting to see those because we're well integrated with the humans that are watching as well as listening. I wanted to just articulate a couple of questions. I've always thought of these, things you can do with hydrophones is broken into a couple of categories, like the applied and the basic biology questions. And we've been over on this side for a long time, and I'm really eager to partner with groups like BC Hydrophone Network that have been doing a better job, I think, of getting bioacoustic insights from hydrophones that are out on the edge of the internet. So yeah, I guess there's some questions here about that we could talk more about, like how do you get reliable enough indications of presence? And every end user seems to have slightly different preference for how many false positives they can tolerate and how confident they want you to be that you really are, the Southern residents are there. So I think that's, and the other thing we're running into is, different end users want different notifications. Like not everybody wants to know where they are all the time. Sometimes they only want to know when they're in their neighborhood, or not Southern residents, only humpbacks. So I think we're going to need to keep adjusting the end user tools and specifically how folks are notified. Yeah, I think I mentioned the long-term conservation challenge. So I just wanted to highlight what I've been observing in the last few years, which is how well the sighting networks are working. Monica mentioned how many different Facebook groups there are, but it's really phenomenal to watch, particularly down in Puget Sound. We not only have sightings coming in, but we have they're really getting vetted in real time. So if it comes in on a acoustic app, we have people listening and vetting the machine detections. In the upper right, those are rows of button pushes in the web app, so those can be validated by experts. You can replay them and assess whether the label really was orcas, exclamation point, exclamation point. But that is part of the challenge, is coming up with ways of moderating this detection stream. So we start to talk a little bit about the architecture, and the machine learning pipeline is part of it, but the moderation, that sort of where's the human in the loop, is I think another challenge. Yeah, so, but I think there's also opportunities there, which I alluded to. In this track, these are locations from visual sightings or acoustic sightings at Fort Townsend and Bush Point hydrophone nodes. And each one comes with some comments now about where did it come from, and you'll see that confirmed as JPOD. So now we're getting down to a little bit more granularity than Southern Resident Killer Whale ecotype. And the cool thing that's been happening is that people have been buying better and better cameras and lenses. And so the same folks who are pushing the button on your web app or participating in your sighting network are starting to create ID quality photos. And I think they're totally capable of figuring out what the IDs are themselves. But before they can, look through the relevant catalog, there's somebody else on Facebook who is an expert and who automatically, almost in real time, is identifying what this individual is, or at least the match line. So in real time on Facebook, which is just a web application, you see the best use of Facebook that I've observed, which is, and I guess it's happening on Discord too. I think that was mentioned for the Saturna community. So I think the future is bright, but it is also complicated and decentralized in ways that make it difficult to share data and to put it on a map. So I guess that's a plea to, as we build out this infrastructure, to think about APIs and licensing early so that it's easier for the data to flow and not get siloed or just lost. So this is kind of what version 1 was above that gray dotted line. Version 2 and 3 are sort of emerging below. Basically, the main goal I have for next year is that orange conservation action. So given that we have a fledgling AI and humans working together, when we send out the notification, how do we turn that into conservation action? So right now, it's been a slow, about 10 subscribers per week via the web app, which has a little banner that says, sign me up for notifications. So figuring out how to leverage those listeners who are really only half local and half global into taking actions that are relevant is kind of cool challenge that I think we'll prioritize in our feature development. We've also been learning that good practice, at least in large software firms, is to study the user and study them early. So we're spending a lot of time learning about user-centered design. Instead of just deciding what to build next ourselves, this is driven by a roadmap where you can give us a feature suggestion and you can vote up other feature suggestions and sort of tell us what to queue up next. So that all we learned from the user researchers who volunteered with us through hackathons. The other thing is Valentina's here from UW eScience, she's taught us try to build your code in a modular way so that's not specific to Southern residents. So that's another long-term goal, is to try to build our open source repositories on GitHub, make them public from the beginning, and also try to make the code agnostic to the species in the application as much as possible. We're not fully, it's messy, we're not fully successful there, but we're learning along the way, and that's actually a lot of what Ben will talk about in his talk. So yeah, thank you again to the volunteers who built most of this. At the end, I'll invite you all to participate in these upcoming hackathons. There's one in December. There's 2 coming up in September this month. So, and there'll be more. So there's opportunities to actually participate if you want to. All of our code is on GitHub at github.com/ORCASOUND if you want to explore it. And we have a Slack workspace that you're all invited to for day-to-day interactions.